I've ridden 15,000 kilometers on these Shimano pedals in all weather and in all seasons, and of course by now they've developed a creak, especially when you push hard on the pedals. I don't want a creaky pedal set, so I took one apart so far. In this video I'll show you what's inside the pedals, how the bearings look like, how the components fit back together, and the tools that I used to get this done. Let's start with the model number, which is visible on the pedal here. It is right above the word Malaysia. PD, I guess, stands for pedal -M520. When I type in Shimano's website this pedal number, I try to look up a maintenance manual, a technician's manual, some service manual, something about these pedals, and the only document that comes up is a single page. It's a PDF, and there's nothing about maintenance. It's got shoes, cleats, how to fit the pedal to the crank arm, how to adjust the spring tension on the pedals for fitting the cleat on. Those are important, but nothing about what's inside and how to maintain it. I guess the manufacturer just expects you to throw the pedal away and hand over your money and get a new set. Well, that's not happening with me. So I took it apart knowing that by the time the pedal gets to a point of creak, the bearings are worn, the raceways are worn, the balls are worn, and maintaining them is going to be giving suboptimal performance. It's going to be better than a creaky pedal, but it's not going to be as good as new. So with that in mind, I still wanted to maintain and want to maintain my old pedal set. I figure I can get 2 or 3 maintenance periods before the raceways, the contact surfaces, the bearing balls wear away to such a degree that they're not worth keeping and needing replacements. So this would be maintenance number 1. I guess 2 more sets of 15,000 kilometers are good to go for these pedals. I really don't know. So inside the pedal body, what you can see is a long threaded section, about 1 inch long, just eyeballing it, and at the bottom of this pedal body you can see it's bare metal, it's clean. There's nothing now, but there was a puddle of grease, soft grease, and that looked like that kind of stuff. You get the idea. Soft, wet grease. So either grease mixed with water that leaked in, or just very soft grease. The replacement grease that I'm going to be using is this, and it's got a softness. It's NLGI number 2 grease. It's not a premium bearing grease. It's a very simple, multi-purpose, clean grease. So that's what I'm going to use. It's not the softest grease. Soft grease will result in less friction or less resistance, less pedaling resistance, and stiff greases, hard greases, will obviously cause more power loss through rotating the bearing balls through a stiffer grease. I hope that makes sense. So that's my choice, number 2 grease. If you want to go with softer grease, go ahead. The bearing balls and all the components are in this tray. The bearing balls are small, 3/32 of an inch, or in metric it's that many millimeters, or in decimal inches it's that many decimal inches. So let me show you the components in a dry fit. So dry fit means I'm not gonna put grease on any of this stuff. I'm not even gonna bother putting the bearing balls into their places, but I will indicate their places. So this is a seal This is a plastic sleeve, and these are components of the, this is your bearing, outer raceway, okay, a sleeve, a nut, and this nut just closes everything off, or that's the final nut to put in place. Two sets of 12 bearing balls of this size. So on the pedal spindle, first is a rubber seal that looks like this when it's clean. Of course, this is gonna be clogged up with hair that gets, or fiber from garments or wherever, that gets wrapped around this, possibly tight, and that goes on the spindle. The spindle looks like this when it's cleaned off the grease. This component might move on it. It looks like it's not at the end of the threaded section just yet, but I haven't touched it and it's not moving on it. There might be thread lock on it. I didn't touch it and I don't want to. So the seal goes on in this orientation, like so, when it's positioned exactly the same way as it was found, and it's meaningful this way. Then the sleeve, this plastic sleeve goes on. This had a lot of, this is where the source of creaking was, because dirt goes in from this side here and interferes with on this surface with just the grease that's underneath this sleeve. This sleeve is going to be rotating when you're pedaling, so it's important to have grease on this surface here between the plastic and the pedal spindle, and that grease also keeps the water out from the bearing, which is here. Two sets of bearings are here, far enough away from source of water ingress. Nevertheless, this is not a waterproof design. The bearings are angular contact bearings, and they are not sealed in any other way besides having this one rubber seal here and hoping that this length of this plastic sleeve keeps the water and dirt far enough away from the bearings that come here. So for the bearing has these three components and then this lock nut. The first one to go on is this ring that looks like this. It's flat on one side, like so, and is angular on the other side, and you can see a shiny surface on it there, a shiny edge on it. This is where the bearing balls run on it. It goes in this orientation, like so, on the pedal spindle, like so. So flat side against the plastic sleeve, and the groove is space for grease. That's also where the balls are held in place, so you're gonna have to dab a little grease on your finger, take one ball at a time and place it and carefully count them, whatever. Here is a tweezer. Oh, here is one of the pieces of threads that I found wrapped around the seal. You get the idea what comes out of this stuff. What comes out of this seal here at that point. So that's one part of the bearing there, 12 pieces of balls on it. Then on this sleeve you'll find a little tapered edge there. You will see there is an outer raceway machined into this sleeve there, and another outer raceway machined into it at the opposite end. So this taper that's on the outside points towards the end of the pedal. So with this motion you will enclose a set of 12 bearing balls there and make sure they are nicely running there. And in this outer raceway there, you're gonna need to place the second set of 12 bearing balls, and this is gonna be the, it looks like a nut, but it's also got a surface for the inner raceway. Everything is tiny, so this inner raceway gets on like so. Of course you need to put 12 pieces of bearing balls there, and let's see, oh yeah, it's threaded this way, my bad. So this is the drive side, and on angular contact bearings, this is what angular contact bearing means. So there's going to be one set of 12 balls, the other set of 12 balls there. So how much you tighten this nut will compress the bearing balls, and they need to be not loose, but if you over tighten this, it's going to be an additional source of friction. Instead of rotating the pedal easily, if this one is over tightened, it's going to be rotating with some resistance, causing additional wear on the bearing balls unnecessarily. So this has to be just right. Where is just right? You're going to have to spin the pedal, spin the bearings, and just feel it. There really is no other way. And this is a lock nut that has clearly visible, let me just focus the camera, blue thread lock on it. Maybe the clearly visible is a little exaggeration, but you can see components or pieces of blue thread lock. So this one goes on last, like so. And the thread lock is, of course, the thread lock is still on the end of the pedal spindle here. And there you can see it. So this is roughly what you see when, of course, it's all gonna be greasy and mucky and whatever. And I guess I can't get that one started, so we'll just leave it off, and the pedal goes on like so by spinning the plastic sleeve into this long threaded portion. Okay, I hope that makes sense. So let's take apart the other one that hasn't been messed with. I'm just gonna leave these on, they are not falling off, and we'll put this one on later. I'm gonna move the bicycle around like so, and I have my setup worked out, whoops, here close to the ground, so the bearing balls don't bob around uncontrollably, bouncing around everywhere, because I really don't want to spend hours finding bearing balls. So the lock nut is gonna come off with this 7mm let's see, yeah, 7mm socket. And besides that, I have a pair of pliers, like so, slip joint pliers, and a 15mm wrench that is a pedal wrench, but you don't have to use it there. I'm just gonna use it here, like so, to hold the pedal this way. On the pedals, on this plastic sleeve, there is a word that says tighten and a directional arrow. I'll try to get a shot of it. Let's see, maybe the other one from the other side is gonna be easier. Let me just take off the last nut that went on. Just give me a sec. Okay, nut is off, metal sleeve off, ring, and plastic sleeve. Okay, so on the plastic sleeve there is the word tighten and the directional arrow there, and I hope it's pretty clear there. So it removes by spinning it the other way, and of course drive side and non-drive side side pedals spin or are threaded the other way. So actually I'm gonna hold the plastic sleeve this way, and I'm just trying to stay out of the picture as much as possible so you can see how this is done. There. So this much force is needed to get the pedal off its spindle. I'm holding the black plastic sleeve with the pair of pliers, and this pedal is kinda seezy or hard to take off. There's a lot of crud in the thread. Yeah. Needs a little force, but it's gonna be nice and clean shortly. And thereabouts. It's easier now. Alright. So here we have the other pedal body. It's kinda clean, but the bottom of it has some of the grease that leaked out. The grease is... okay, I was slightly wrong previously. The grease, of course, is everywhere. If I wipe off the end, you can see the lock nut. You can see this nut which provides the inner raceway for the bearing. You can see the bearing balls behind it. They are spinning alright, or they feel like they spin okay. And then we've got this ring here, and the set of 12 bearing balls in this gap, and of course the other set of 12 bearing balls in this gap. Okay, so I'm gonna need my 7mm wrench. I really don't know the tightening torque on this nut here at the end. I'll just try to take it off with whatever there. About yay much force is needed to take it off. And this is the non-drive side, so this one is threaded the usual way. So that's the lock ring. And this is the first nut behind which the first 12 bearing balls are, and they start coming out like so. I notice the camera goes out of focus, but I'm trying to keep it all together. So you can see this is the conical surface on this nut here that forms the bearing. This is going to be a bit of a challenge here with putting the bearing balls back in place. You can see the tapered surface on this metal sleeve is facing the end of the pedal. So that's that. And there is the other set of 12 bearing balls looking like this initially. That's fine. And lastly, this ring whose flat side was against this plastic sleeve there. That's how it looks like when it's all yucky and dirty and some hair or whatever on it. So I'm going to be cleaning this a while and then replacing it with fresh grease, assembling it in the reverse order that I found it. Thank you very much for watching.